Hi everyone, welcome to 5.4 Exponential and Log Equations. Today's lesson is a little more exciting than the 5.3, which was, I think, very filled with it was filled with rules and trying to figure out what we need to do to be able to apply our log laws. Taking a look at today's examples, the first two are actually things that you would have seen from 5.3. Now, if it says for 1a to solve by logarithms, we could do one of two things. If we look at this, we should be able to know that the answer is going to be 3. But if you put that into log form, right now it's in exponential form, you could say that would be log base 2 of 8, and that's going to equal 3. Now, for something else, I guess you could also say we could log both sides. And if you logged both sides, remember the soccer kick rule makes the x kick in front. And then if you divide by log 2, then you could say you would get something like that. And that does simplify to 3, but probably I wouldn't consider doing that way. For part B, we get an answer that's not going to be as clean. If we put it into log form, you would say log base 3 of 11 equals x. And then if you put that into the calculator, it doesn't say how many decimal places to round it to, but if we round it to 2 decimal places, you could get something like 2.18. Okay, so that's more of a review from 5.3. On to some questions that now really make us think a little bit more. So if you have something like 2a, and we have 2 logs on the same side, and they're both with the same base, and they're being added together, we could join those as a single log using our product rule. And if you write that, you could get x times x plus 3. And I'll write the x in front just so it looks a little bit cleaner. And now that you have something like this, how could you solve for x? Well, you have a single log. We have logs on one side. There's a base of 10, and whenever you have a single log, you can put it into exponential form. 10 to the power of 1 is going to equal x times x plus 3. 10 is going to equal x squared plus 3x. And then we can get everything onto one side. We would have a trinomial that we could factor. So let's bring everything onto the right side. And now if you solve for this, you could get something that would say x plus 5, x minus 2. So x equals negative 5 and x equals 2. And this seems great, but there's one thing we need to do, and you've done this in so many other units this year. We need to check to make sure that our answers are accepted and that they're not extraneous. So take a look at what you have, and we know that where you have your argument with this x plus 3 and this x, you could never have something that would give a value of less than 0. And so if I take this negative 5 and I put it in for x, or if I had put it in here for the x plus 3, I would be creating something that would have a negative argument there. So this gets rejected. And we only accept x equals 2. And that's how it goes. So basically, in a lot of these questions, you're going to have to consider if you reject one of your solutions, maybe both of your solutions, but make sure you always do a check for these. Question B, let's join this as a single log. And once you have a single log, let's put it into exponential form. 8 to the power of 1 equals, I'm going to FOIL this out, x squared minus 6x plus 8. It's kind of a weird example because if I brought the 8 over, if I subtracted this 8 onto this side, the 8's actually cancel out. and whoops, and I'd be left with 0 equals x squared minus 6x. So from here, we could factor out an x, and we would get solutions of x equals 0 and x equals 6. If you take that 0 and you sub it in here, or if you'd subbed it in here, you would produce a negative argument. And so because of that, that gets rejected, and x equals 6. And if I put a 6 in here, that's okay. And if I put a 6 in here, that's okay. There's a chance you may be rejecting both solutions, but in this case, x equals 6 works out just fine. Okay, so what would happen for something in which we have logs on both sides? This is the worst thing you can do. Don't do this. Don't do this. Log 3, log 3, log 3. You can't just cross off something like that and make it much easier. If you do that, I can't even give you half a mark. There's it would be the equivalent of saying something like this. 3 squared plus 4 squared equals 5 squared. Oh, I'm going to cross off all the squareds, and then 3 plus 4 is equal to 5. You can't do that. Okay. What we can do, though, is we could write this left side as a single log because they share a same base. And if we do that, we would now have something that looks like this. And if you look at the left side and you look at the right side, they're both logs of base 3. And because they're both logs of base 3, then that means that this x plus 6 over x plus 2 must be equal to that x. So you can drop the logs. And you could say x plus 6 over x plus 2 equals x times both sides by x plus 2. And you would get x plus 6 equals x squared plus 2x. Let's bring everything onto one side. And you would get x squared plus x minus 6, which could become x plus 3, x minus 2, and then you would have a solution of x equals negative 3 and x equals positive 2. Well, you need to go check to see if these are accepted or not accepted. And when you take this negative 3 and you put that in there, you know that you'd be producing something negative for your argument, so that gets rejected. And so only x could equal 2. So if at any time, I could have subbed it in there, if at any time there's something that would produce an argument that would be less than or equal to 0, you have to reject it. Okay, now for this next question, these are starting to get a little bit repetitive. I could say it's a log base 5 of x minus 3 over x equals log base 5 of 10. They're both log base 5s. So then you could say I can drop the logs and I have x minus 3 over x equals 10 times both sides by x. X minus 3 equals 10x. So that means that x is going to end up being negative 1/3. And you only get one solution here. And when you go back and you take a look at it, you can't even accept that solution because you would have something with a negative. So that doesn't work, which means this just has no solution. There's no number, no real number that you could put in for x to make that left side equal that right side, and you'd have to just say no solution. For example 4, you do want to rearrange things as it says in the question. You could do this multiple ways. So for instance, it looks like you want to have something in terms of logs with bases of 3. So what you could do is you could rewrite where this says a 1 right here. You could rewrite that as saying log base 3 of 3 and then just join the left side and join the right side. Or if you want, you could try to keep that 1 isolated on the right side and bring this log base 3 of 2x onto the left side. So there's multiple ways to be able to do this question. for what I think might be easiest, I'm going to bring this 2 up top here, and I'm going to join this left side. I'm going to say log base 3 of x squared times x minus 1. And that's going to be equal to, instead of saying the number 1, I'm going to say log base 3 of 3. That's equivalent to the number 1 plus log base 3 of 2x. So then from here, on the left side, I can expand what we have. So we could say it would become x cubed minus x squared equals log base 3 of, and then it would be 3 times 2x. So from there, you could say, well, the left side and the right side both have log base 3's. So I can drop the logs, and then we could say x cubed minus x squared, equals 6x. Let's subtract 6x onto the left side, and then we could factor out an x. So you could say, if I factor an x, I'd have x squared minus x minus 6, and that would give me x minus 3, x plus 2. And so then I would get a solution of x equals 0, x equals 3, and x equals negative 2. So you go up, you do your checks, you know that x couldn't be 0, and x couldn't be negative 2. So your only solution would be x is equal to 3. Again, there's multiple ways to do that question, and if you wanted to, I can show you some more ways in class, but that's one good way of being able to do it. Okay, now this next question is, I don't know, I'll put a star next to it just because math teachers really like to ask a question like this. It's so tempting to look at this question and to say, 3 times 2 is going to give me a base 6, and once I have a base 6 on the left side and a base 6 on the right side, then I can just drop the logs. But we can't do that because that wouldn't be proper BEDMAS. Taking a look at something like that, this 2 belongs to the power of x plus 2, but the 3 doesn't. So what you'd have to do is you'd have to say log 3 of 2x minus 2 equals log 6 to the x. So we've logged both sides here. On the left side, I can now expand this into 2 separate logs being added together because I have a log with multiplication happening inside. So log 3 plus log 2 to the x minus 2 equals x log 6. I'm just going to soccer kick that in front. This x minus 2 could actually kick in front here as well. And I could get log 3 plus x minus 2 log 2 equals x log 6. I should write that a little cleaner. Now, the x minus 2 is being times by the number log 2. So I'm going to actually expand that. And we're allowed to because log 2 is just some decimal number, and you're just expanding that into the brackets. And you could get something that says log 3 plus x log 2 minus 2 log 2 equals x log 6. What do we do here? If these logs are just representing some sort of decimal numbers and you have 4 terms, you got this guy, this guy, this guy, and this guy. 2 of the 4 terms have x's, and 2 of the 4 terms don't have x's. So you want to get your x's together and your non-x's together, and then you want to be able to solve for x. So let's take this x log 2 and let's subtract it onto the left or the right side. And if you do that, then you'd be left with something that would say log 3 subtract 2 log 2 is equal to x log 6 subtract x log 2. On the right side, you could factor out an x. And if you factor out an x, then you'd be left with log 6 subtract log 2. And that's really nice because once you've done that, that x is now being times by that bracket. And if it's being times by that bracket, you could divide by log 6 minus log 2. And you could divide this by log 6 minus log 2. And we have x isolated. So here's one thing. You're going to have a few questions like this in Michelson. And if you leave your solution like this, I would fully accept that. Michelson will probably simplify. He does simplify a lot more, where he'll take the numerator and he'll try and turn that into a single log, and the denominator, he'll turn that into a single log. What I mean by that is you could say, for instance, this log 6 minus log 2, you could technically write that as log 6 over 2, which is just saying log 3. And you could start to do some things with that. I'm happy just leaving it like this. And when you look at his work solutions, which are done really well, you'll see that as part of the process. And I'm okay to stop right there. But if you look in the back at the final answer and it doesn't match up with yours, it's just because he ends up simplifying a little bit more than what I think is necessary. We've expressed it in terms of logarithms, but just know that you could sometimes do a little bit more. Okay, example 6. So now, this is a tough question. It says, if log 3 equals a and log 8 equals b, determine log 18 in terms of a and b. And 18 doesn't naturally fit with multiples of 3s and 8s. It actually seems a little bit awkward. And so if you think about log 18, how could you split up log 18 to be able to write it as a factor where you might be able to change it into something with 3s and 8s? And if you think about that, I don't think that 3 and 6 would help us, because the 6 would have nothing to do with the 3 or the 8. But if you changed it to log 2 times 9, then you could get something that could say log 2 plus log 9. Now, what do we know about some of these parts here? Well, let's see. Log 8 equals b. So that means that log 2 cubed equals b, which means that 3 log 2 equals b, which means that log 2 would be equal to 1/3 of a b. So where this says log 2, I can now write 1/3 of a b. And I've expressed that in terms of a's and b's, or b's in this case. For log 9, well, what could we do with something like that? If log 3 is equal to a, then couldn't we say that log 9 is the same as saying log 3 squared? And if that's the case, then it would be the same as saying 2 log 3. And wherever I have a log 3, I know that's equal to an a. So I could say I have 1/3 b plus 2, and instead of saying log 3, I could say a. I'm not sure if I said that in the best way possible. A couple of you are probably going to pause that, rewind it, and re-look at it. But that's the way that I would see it. Just before you go on, another thing that you could have done is if you didn't like this part right here with the 8s, I guess I don't think this is going to be any better, but you could also look at log 2. Seeing it as log 8 to the 1/3. That's the same as saying the cubic root of 8. And if you can do that, then you would have 1/3 log 2, or sorry, log 8. And if you had something like that, then you know that you would have 1/3 of a b. So that would be exactly the same, but that part's tough. It doesn't come too naturally. So whatever you do, both methods work. Okay, so with log equations, we've actually done fairly straightforward log questions. Here's two questions that really challenge us. The first one especially, it looks nasty. And you can play around with it, you can pause it, and I recommend you try that, especially if you're looking for a challenge here. What's the value of x? The second one is interesting because it's the first time we've done a question in which we don't have the same bases. We have a base of 16 and 4 and 2, and they look related, but they're not the same. So both these questions are pretty nasty. I'd say A is definitely probably a little more challenging than B, but give yourself a chance to be able to try these out and see what you could come up with, and then I'll go through the solutions right after. Okay, so with part A, I don't know. Here's what I would do. I would play around with it, and I'm sure you did the same. But one thing that you can do is you could log both sides. And if you log both sides, that's going to create a huge advantage because this log x can kick in front, and you essentially create something that would say log x times log x. And that's going to equal, I'm going to distribute this into, say, log 100 plus log x. But log x times log x, what does that equal? Well, we haven't times a log by a log, but it's the same thing twice. And if you have the letter a and you times it by a, you would get a squared. So with something like this, you're going to get log x squared. And it would equal log 100, which I'm just going to say is 2, plus log x. But now instead of saying log x, I'm going to say let log x equal a. And you could say something like this. A squared equals 2 plus a, because that's log x again. And now you have a trinomial that you can factor. So let's bring everything onto the left side. And if you do that, a would be equal to 2 and a would be equal to -1. Now that on its own doesn't mean much because that's only what a is. And remember, log x is equal to a. So now, instead of saying that, you could say, well, wherever there's an a, I can now say log x equals 2 and log x equals -1. Well, what would be the value for x when you have log x equals 2? Well, if you have something like that, you'd have to say, I'm going to put that in exponential form. And 10 to the power of 2 equals x. So that means my first answer is going to be the number 100. And then over here, I could say, well, 10 to the power of -1 is going to be equal to x. So I get 1/10 would be my second solution. And you could check them, and both numbers are allowed to go in there, and we have two solutions. You get 100 and you get 1/10. So definitely a bit of an awkward question, but I think that some of you will really enjoy that challenge. Okay, so for part B, what do you do when you have different bases? I guess I would say you have to make your bases the same. And I'm going to do this maybe not the most efficient way, but I think this is the way that hopefully will resonate best with you. I'm going to write each of these in a change of base form. And here's why. Because now that we have them in a change of base form, I can change that 16 in the log 16 to say something like 2 to the power of 4. And I could change this log 4 to say 2 to the power of 2, and I could say, given that, I now have something in which they look a little bit more similar than they did before. Now, this 4 is the exponent. I'm going to kick in front, and this 2 is the exponent. I'm going to kick in front. And so what you end up with is something that would look like this. You have a quarter of log x over log 2. And whoa. And then you have a half of log x over log 2. And then you have 1 log x over log 2 equals 7. Well, can we do something with that? Could we join them? If I have a quarter of something plus 1 of something plus, a quarter of something plus a half of something plus 1 of something, I should be able to join those all together. They're like terms. They're all of the exact same log x over log 2. And so if you take a quarter plus a half plus 1, well, what do you get? Well, I guess we should probably say you should have a common denominator. And you could do something like this. You could have 1 quarter of log x over log 2 plus 2/4 of log x over log 2 plus 4/4 of log x over log 2. And that would equal 7 over 4. And instead of saying log x over log 2, you could even undo the change of base. Okay, so think back to your change of base rule. We had it in some sort of expanded fractional form, and we've just undone it to its original form. And then you could times both sides by 4 over 7. And you would get something that would say log base 2 of x equals 4. And then that means that x is going to equal 2 to the power of 4, which is just 16. Well, what would happen if you sub that in here? If you had 16 and 16 and 16, log base 16 of 16 is the number 1. Log base 4 of 16 is 2, and log base 2 of 16 is 4, and 1 plus 2 plus 4 equals 7. So we definitely did that correctly. Okay, pretty crazy question. Here's some homework. There's a bunch more crazy questions that you're going to be able to work on, and I think you'll have a lot of fun with them. So thanks for joining us, and now you can officially log off.